This is part C of Introduction to Objects in Python, week 1, and I want to talk more about methods. So classes have methods, and methods are basically functions attached to an object. What that means is when you run the function, it functions inside of an object. It has access to the values of the variables for a particular object. Remember, functions tend to be freestanding, all the way left justified, def, function name, and you can use them anywhere. Methods are inside the object, so they're tabbed over. When we use them, you see this, right? So like print is, you just say print. You don't have to attach it to an object. But when you want to turn something into uppercase, you have to say what it is you're turning into uppercase, right? There has to be a string name, dot, and then upper. Or a line if you're splitting it. Where the commas are, you have to say which line you're splitting. So methods are attached to a particular object, and they work on the data in that particular object when you run them. Now, a lot of the stuff with methods, it's just like functions, right? So they can have a return value. You can send them parameters, right? You put parameters in the parentheses, and that's how you send it to the method. And they're indented. So under the definition line, the code for the method is indented one hop. So here's the definition line for a method. And note, this goes inside the class, right? Because classes contain attributes and methods. Well, here's the method. So this is inside of a class, indented underneath the class definition. And here's that word self. Methods use the word self to refer to the object that you're in, the object that this method is called on. So remember, here's how you call a method name. You've got the object, some variable, dot, and then there's the method name with parentheses. So parentheses, just like functions. Variable name is the name of the object, not the class. This is a common mistake, so just try to make a note of it. You have to have a specific named, variable named object, not the whole class. Right? And this makes sense. If you had a method that says, what's this vehicle's top speed? You can't ask in general vehicle top speed. You have to ask it on a specific vehicle. Oh, this specific vehicle has a top speed of 50 miles an hour, and this one has a top speed of 150, right? So methods are called on a specific object, and you name that object, the variable name that holds that object, right? It's just like when we were sorting a list. You can't say sort. You can't say list.sort. Just in general, you have to give a particular list that you want sorted. That's how you call a method. So here's a slightly more detailed example. We've got a class vehicle. It has a start engine method defined here in the class. So if you have a vehicle, car1, right? Car1 is the object of type vehicle. We can say car1.startEngine. And the word self in the definition matches up with the particular object that you're calling start engine on. So if start engine, the method, does something to do with the values that are in this car object, it's going to do it in car1. Now we saw this before with the constructor method, the init method. Methods, just like functions, can have parameters. You leave that self at the beginning when it's the invisible first parameter, but you can add as many other parameters as you want. And you can define a return value. If when you call this method, if it gives you something back, put in the return. There you go. Here's a little more detailed example. We've got a class vehicle. Here's a definition of a calc trip cost. And you'll notice it's got a parameter, miles. How far are you going? Now, we've omitted the actual calculations, but the function eventually figures out total cost and returns it. So we make a car vehicle called, a vehicle type. The actual variable name is car1. And so now when we call the function, the self is the car1. And the miles is the parameter. It's the only parameter we see in the function call, but it's the first parameter, ignoring the invisible self parameter. And then don't forget the return value. The return value replaces the function call, and with the equal sign, we can put that return value into this cost variable in main. And that's also an easy one to forget, so try not to forget it. If your function returns something, you have to store it. You have to put it somewhere. If you just write the line without this cost equals, and then you're looking at the next line to recover that value, sorry, it's gone. So you need to assign return values into some variable. And you can also just print them if all you need is that value for just right then and there. But almost always, it's good to put it in a variable. And now I want to talk about the underscore underscore str underscore underscore method, or I'm just going to call it the str method. And this method turns whatever it is you have into a string so you can print it. And furthermore, there's an automatic mechanism in Python to call this method when you try to print something. So we've actually been getting away with this for a while, because if you try to print a number, just the number by itself, you don't get that error message you do when you try to glue it onto the end of a string. It prints a number because there's an str method that knows how to convert it. When you try to print a list isn't a string, but it prints. How? There's an str method in list that says, well, you want to print this thing? Okay, here's a string. We'll turn the list into a string, and then you can print it. Now, you don't have to print it. You can store the string in a variable and do whatever you want with it, but that's what this method is for. So here's an example of the str method, def underscore underscore str underscore underscore self, right? Because this is a method inside an object. It's going to print the particular object that it's called on, and it returns, in this case, it just returns this string. I don't know where the data is, but that's what this one claims that you print when you want to see what's in an object of whatever type this is. Important to note, it returns a string. It does not print a string. You do not call the str method to print it. You call print on the string to print it if you want to print the string. So here's an actual one that you might have in the vehicle class. We're defining the str method. Notice there's the self. And we're accessing self.make. So for this particular object, self.make is who made that object. And self.model is what model is it. So Ford, Fiesta, and then we return that information. We don't print it, we return it. Now you might notice, well, the miles per gallon isn't included. Sure, there's a ton of stuff that might not be included, right? This is Python giving us, the programmer, control. If you want to print something out, you can print out whatever you want to know. If you don't need to know the value of every attribute that's in your objects, okay, just print what you want. All right, so here's that in action. We have a car object equals vehicle. Oh, this is a constructor call, right? So the constructor stores, and we've seen this is way back there somewhere. We store Mario Kart, I guess that's the make, a zip, I guess that's the model. Anyway, that all gets put in the constructor. Then we just say print car 3. Where's the call to the underscore str method? It's automatic. Whenever you try to print something that's not a string, it goes, oh, we should call the string method to convert this thing into a string, and then we'll print that. And so we use the method that we had on the previous slide, prints out the make, prints out the model, and that's apparently what we want to know about a vehicle when we try to print it. Okay, so that is the end of the week 1 videos for this Intro to Objects in Python.